Alrighty, hi girls. So this is a video about solving quadratic, and I've written and other inequalities. It's basically about using graphs to solve inequalities, which is very important and something that is much more applicable than solving linear inequalities is basically what we've done up until now. Oops, that should have been a 0. So let's say I want to solve this inequality here, right? So the basic method you apply is you effectively relabel that as y equals, and then you draw the quadratic. Now I'm going to attempt some technical wizardry here, so hold on. Isn't that impressive? So I've taken the time to put the graph into Desmos. So what this is saying is it's saying I want to know when the y values of this graph are bigger than 0 or equal to 0. So if you look at the curve, it's all of these sections here, right? Those two things are where the graph is above the y-axis, and so that y is bigger than 0. But more importantly than that, the thing that I want you to take away from this video is that there's a change that happens, and the change that happens is when y equals 0. What I mean by that is, as you go from left to right, oops, I think I did something. As you go from left to right, the graph is above 0, in which case it satisfies the inequality. It hits 0, and this is when the change happens, and then it's below 0, at which point it doesn't satisfy the inequality. So the general method for solving these things is we identify when that change happens. So we say, alright, when does x squared minus 3x plus 2 equals 0? And we solve that as usual. And then, after we've done that, and the reason we do this is basically because it always works. Now we draw a sign diagram, and I'd like you to spell that for me, Alexia. So, there's 1, there's 2. And literally what you're doing is you're just assessing values in each of these three regions on the number line. Right, this is the number line for x. And you're assessing whether or not the original inequality is true there. Okay? Because if it's true, the idea is, right, because it changes at these points, as we talked about before, if it's true anywhere in this region, then it's true in that whole region. And similarly, if it's false anywhere in there, then it's false everywhere. Okay? So we pick a value, and you just pick nice values. So a number less than 1 is 0, and you sub it in, so 0 minus 1 times 0 minus 2, so that's minus 1 times minus 2, which is a positive number, so it works. And then in the middle we pick a number, 1.5, so 1.5 minus 1, so that's positive 1/2, times 1.5 minus 2, so that's negative 1/2, that's a negative number. Doesn't work. Pick a number over here, 3, so that gives me 2 times 1, which is positive, works. And that tells me that the solution is everything to the left of 1, everything to the right of 2. Okay, well, let me show you another example. Again, prepare for some technical wizardry. Okay, so we're trying to solve 1 on x plus 2 is bigger than 3. It's the same idea. You essentially imagine that these things are, you essentially imagine that they are y equals for both of them. And then you say, well, when is 1 on x plus 2 bigger than 3? Here's a graph, right? You can see that there's two possibilities for when that changes from true to false, right? The first possibility is the obvious one. As you pass through the 3, you change from above it, so true, to below it, false. The other case, which isn't quite as obvious, is here, at the horizontal asymptote, when the blue curve jumps from negative infinity to positive infinity, right? You can see that down here it is false, and over here it is true. So we do the same thing as before. We start by identifying those two things. We identify when they meet and when there's an asymptote. Okay? So firstly, the asymptote, x plus 2 cannot be 0, so x cannot be minus 2. That's going to be our first element on our sign diagram. 1 on x plus 2 equals 3. So that's x plus 2 equals a third. So that's x equals minus what's it? 2 is 6 thirds, sorry, so that's minus 5 thirds. So those are our critical values on our number line that we're going to do a sign diagram for. Alright? Just going to give myself some space. So we've got our sign diagram. Minus 2. And I'll just give myself a lot of space, minus 5 thirds. And there's x. So again, we check some values. Nice one to check over here is 0. Right, over here, I should say. You can't see me pointing at my screen, can you? So, when it's 0, it's 1 on 2. Is that bigger than 3? No, doesn't work. And in here, so you have to pick a value between minus 2 and minus 5 thirds. So that would be minus 11/6. I'm actually not going to do that, but you could do it in your calculator. Then if I pick a number left of 2, so that's minus 10, let's say. So I say 1 on minus 8. Is that bigger than 3? No, definitely not. And it turns out that if you check this one, it's true. And you'll notice that unless something really weird happens, there's this pattern of either false, true, false, or, as we had before, true, false, true. And that pattern will essentially always hold. And so then our solution is, well, it's between minus 2 and minus 5 thirds. And you must write it like this. If it's between, you cannot write it as two separate inequalities. Okay. Notice as well, if I were to change the question, and I want it to be greater than or equal to, it wouldn't actually change both of these inequalities, it would only change that one, because x cannot equal minus 2 by definition of this equation here. Okay. One more example. Okay. So minus 1 on x is less than or equal to 2x plus 3. I've mapped them again. So literally, once again, it's about when is one curve above the other. And you'll notice when it changes. So it changes when they meet, and then it changes here, at the asymptote, right? When the 1 on x, the hyperbola, jumps from positive infinity to negative infinity. The hyperbola jumps from being above to being below. So we do the same thing. We identify those three cases, and we do a number line, we do a sign diagram. So, let me just see, can I delete this? Maybe not. Alright, I might have limited my space here. Alright. So firstly, come on pen. So firstly we know that x can't be 0. That's the asymptote, right, from here. Then we set them equal to one another. Multiply out by x. Add 1. Factorize. So x is equal to minus 1 and minus a half. So we've got 0, and that's a cannot equal, minus 1 minus a half. Okay, number line. Oh, no, I don't want that. And we're talking about minus 1 on x being less than, 2x plus 3. Alright, and then it's about assessing when it's true. So number bigger than 1, let's say, 1, positive, number bigger than 0, sorry. So is negative 1 less than 5? Yes. Number between 0 and minus a half, minus a quarter. So is 4 less than, is that right? Yeah, 4. Is 4 less than 2 times negative a quarter? So what's that? Well, it's a negative number anyway. Plus 3? No, it doesn't work. Because 4 is definitely not less than 3. I check in here. I'll tell you now it will work if I put negative 3/4 in. And if I put in negative 10, let's say, so I get is 1/10 smaller than 2 times negative 10, negative 20 plus 3? No, definitely not. And so that tells me my solution is, remembering that x cannot equal 0, x bigger than 0, or x between minus 1 and minus a half. Okay? that's the end of video number 1, intended for Friday's lesson.